To help us understand fractions, we're going to look at an example. Let's use the example of a pizza. So if I have a whole pizza and I take that pizza and I slice it up and I slice it into 6 evenly divided pieces, and I decide to eat 2 pieces of the pizza, I'm going to shade in the 2 pieces out of the 6 pieces that I decide to eat. I can either say I ate 2 slices or 2 pieces of pizza, or I could say I ate 2 parts of the whole pizza, or I could say I ate 2 parts out of 6 parts of the whole pizza. Similarly, if I take an apple and divide it into 8 equal slices and I eat 5 of them, I could say I ate 5 parts out of the 8 parts of my apple. We use fractions to express parts of a whole. Now, keep in mind that we're using equal parts. And we use fractions anytime we want to talk about the parts that we ate, the part of the apple, the part of the pizza. Fractions help us express parts of a whole. Now let's look at how we write a fraction. There are 3 parts to a fraction. There's the fraction bar, the numerator, and the denominator. The numerator is the number that's going to go on top, and the denominator is the number that's going to go on the bottom. Now in this case, the numerator here is representing the number of pieces of pizza that I ate, or the parts that I ate. The denominator here, the 6, is representing the total number of pieces that make up my whole pizza. So in this example, I am going to say that I ate 2 parts out of 6 parts of the pizza, and the fraction would look like 2 over the fraction bar, 6. If I wanted to talk about the number of pieces of pizza that I did not eat, I could also express those as a fraction. The part that I did not eat would go in the numerator, the 4 pieces I did not eat. Then my fraction bar, and my numerator is still 6. There's still 6 total pieces of pizza, and the 6 would go in the denominator. Let's look at one more example for a fraction. So let's take a rectangle in this case. So we've got one whole rectangle, okay? And I'm just going to write a 1 here to represent 1 unit, our entire rectangle. Now, if I take that rectangle and I divide it into 3 equal parts, I can express this part here as 1/3 of the rectangle, because I've made it into 3 total parts, so the 3 in my denominator and the 1 in my numerator. So each of these sections here is 1/3, 1/3, and 1/3. Now if I put 2 of these 1/3s together, and I look again at my rectangle, about right here, I've brought 2 of these 1/3s together, I've got 2/3, and still 1/3 of my rectangle here. Now, if I bring all 3 of my thirds together, 1/3, 1/3, and 1/3 into one rectangle, I've got 3/3, which equals 1. And as you can see, this rectangle is the same as this one. Let's look at one more example using a circle. I've taken my circle and divided it into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. And if I shade in 3 of these parts, and I want to represent the shaded part in a fraction, parts of a whole, I'm going to use the 3 is my parts that I've shaded over my total number of pieces in my circle is 8. So 3/8 represents the shaded portion of my circle. There are several different types of fractions: proper fractions, improper fractions, like fractions. Let's start by looking at proper fractions. A proper fraction is a fraction where the numerator is less than the denominator. So A is a smaller number than B. And in this case, the value of a proper fraction is always less than 1. So 3/4 is an example of a proper fraction where my numerator is less than my denominator and the value of this fraction is less than 1. An improper fraction is a fraction in which my numerator is greater than my denominator. So A is a bigger number than B, and in this case, the value of an improper fraction is always greater than 1. So 7/3 is an example of an improper fraction, and the value of this is greater than 1. Like fractions are two fractions that have the same denominator. So, for example, 2/3 and 4/3 are like fractions because they have the same denominator. Unlike fractions are two fractions that have different denominators. So 3/4 and 5/7 would be two unlike fractions because they have different denominators.